Okay, today we're going to talk about square roots and irrational numbers. So a square root of a number is a number that times itself gives you your original number. So for example, if I asked you what's the square root of 16, it would be 4 because 4 times 4 is 16. But it could also be negative 4 because negative 4 times negative 4 is also 16. So let's look and make our list of what are called perfect squares. So if I take 1 and I multiply it by itself, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 36, 49, 64, 81, and then 100. 11 is 121, 144, 169, 196, 225, 16 squared is, gosh, I think it's 256, but I feel like that's wrong. I was correct, 256, 289, 18 squared is 361, 324, then 19 squared is 361. And then 20 squared is 400. So all these numbers that I just wrote in orange are perfect squares. So what that means is 144 is a perfect square because 12 times 12 is 144. 25 is a perfect square because 5 times 5 is 25. So this is a really helpful little chart to have out because when I'm asking you, like, find the 2 square roots of each number. So the 2 square roots of 25 are 5. But then also negative 5, because we know that a negative times a negative is a positive. Okay, for 1 over 9, what's the square root of 1? 1. And what's the square root of 9? 3. So 1/3 times 1/3 is a 9th, or negative 1/3 times negative 1/3 is positive 1/9. So the next part says, estimate the value of the square root of 28 to the nearest integer. So what that means is we're looking. 28 is not a perfect square, but which one is it closest to? It's closest to 25, and the square root of 25 is 5. So on a number line, this would be closest to 5. So let's look at that with 38. So which one of these numbers is 38 closest to? 36, so the square root is 6. Okay, forget about the negative for right now, but the square root of 100, or 105, is closest to 100. So that's going to be negative, because it's asking you for the negative root of 10. And then for 54, if you look at 54, that's closest to 49, so 7. So it says, recall that you can write rational numbers as the ratio of 2 integers. Irrational numbers are numbers that cannot be written in the form a over b. So an irrational number, you cannot write it as a fraction. So it says, together, rational and irrational numbers form the set of real numbers. And then it says, flip your notes over and we're going to draw a chart. So every number that you have encountered up until this point, 99% sure, is a real number. There are things called unreals and imaginary numbers. That is above our pay grade for right now. So let's talk about what makes up a rational number. Rational numbers can be integers, okay? Integers are your positive and negative whole numbers. So 5, 2, -1, -17. Thank you so much. 1,000. I had someone in here. 1,000, it could be -125, any positive or negative whole number. Then we could have fractions. So 7 over 8, 1 1/2, 45 over 7. Okay, anything that we could write as a fraction, even if they're negative, okay, is a rational number. Then we can have what are called terminating or repeating decimals. A terminating decimal is something like 0.612. It terminated. It just ended. Okay, it could be repeating, 0.8 repeating. It could even be something like 1.217 repeating. It could be negative 11.13475. Okay, any decimal that terminates or keeps on going forever and ever, repeating, is a rational number. So you might be thinking like, well, what is even left to be irrational? Okay, and irrational numbers are numbers that never end and they never repeat. Okay, so literally if you wrote a number like 0.12578342896, on and on and on and on and on. Okay, if it never ever ended and never repeated, then it is irrational. Okay, sometimes irrational numbers look like where it might be like 1, 2, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 2. You can see there's a pattern, but it's still never ending and it's never repeating. So there's a ton of irrational numbers, and what happens, or when we see them a lot, is when it's a square root of a non-perfect square. So for example, the square root of 5. Is there a number that times itself gives us 5? No. Okay, but what if I gave you something like, I'm writing it over here, the square root of 9. What's the square root of 9? 3. That's an integer. The square root of 9 is an integer because the answer is 3. Right? Or the square root of 16, that's 4. That's a whole number, right? The square root of 16 is just another way of writing the number 4. Okay, so square root of 5, there's no number that times itself gives us 5. What about the square root of 18? Is there a number that times itself gives us 18? No, ma'am, there is not. So that is an irrational number. So let's see. An irrational number is, generally speaking, when you have the square root of a number that is not a perfect square. Okay, so it's the square root of a number that's not a perfect square. Perfect squares are being this list of numbers that we wrote plus a bunch of others that we just didn't take time to do. So like the square root of 36, that's a perfect square, right? 36 is a perfect square. If I gave you the square root of 40, that's irrational. That's not a perfect square. So let's look at our little list down here, and we're going to classify each number as rational or irrational. So the square root of 100, that is rational because the square root of 100 is 10, which is a whole number, right? An integer. Okay, what about 0.6, repeating? That's rational. It is a repeating decimal. I could write that as 2 over 3. What about this negative 0.81 repeating? It's rational. It is a repeating decimal. Square root of 70. Ding, 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 ding. Irrational. It is the square root of a non-perfect square. 70 is not on my list, right? If I were to try to type it into my calculator, the square root of 70, I get 8.366600265, and it would actually go on and on and on and on and on. My calculator just ends there. Irrational. Okay, 1 2/9. Rational. It's written as a fraction, right? It's a mixed number, but I could write that as 11 over 9, and it would be rational. Negative 2.6457. That's rational. It is a terminating decimal. It's a decimal, and it has ended. What about the square root of 5? Irrational. There is no number that, well, there technically is, but it's never ending, that you can multiply times itself to give you 5. What about the square root of 49? That's 7, so it's rational. Okay, on this last, or next to last one, 0.81, 811, 8111,